Okay, so hello everyone to this session. So this is going to be an introduction to quantitative analysis and time series analysis. Um, so yeah, I'm going to in this, I'm not assuming that, well, let's say, I'm assuming you have some basic understanding of this stuff, but let's just it's going to be maybe a recap or covering the basic in a way so that and it should be an opportunity for you to ask questions about anything that is not clear for you, especially regarding the application for the challenge you have this week. So without further ado, let's okay, so I hope you can see my screen. If there is any issue, you can stop me at any point. Just raise your hand or you can speak directly. All right, so okay, so quantitative analysis is in short, it's just the analysis of numerical data. It's just whenever any data you have that can be interpreted in numbers, analyzing it is quantitative analysis. It's okay, so it's powered by mathematical and statistical analysis, basically. And it's in contrast with qualitative analysis, which which is the opposite, which when you analyze data that is not numerical, and maybe data that is also can be subjective. It has subjective measures and less rigorous in a sense. So yeah, so basically this is what we're here. It's what we're talking about is the statistical analysis, and I suppose you already have done at least in the first few tasks, in the ADA part, you have already done statistical analysis in that part. So in the descriptive analysis, you descriptive statistic, you have computed. Okay, so generally the statistical analysis or the quantitative analysis aims to do one of main goals is to measure difference between groups or find the relationship between different variables in the data or test a hypothesis in a rigorous way. So this is what is, hypothesis testing and constructing confidence intervals. Okay, so as I said, there are two kinds of statistical analysis, or there are different two branches of statistical methods. You have descriptive statistics and inferential statistics. So yeah, so you can see the definition here, but can you maybe let me make this interactive in a way and ask you what is can you define any of this? Can you define what is descriptive and statistics, or can you give an example of what is something you can compute that is a descriptive statistics? And just feel free, you don't worry about I'm just trying to gauge how much you understand, so don't feel shy. Let me hear from you. You can also write in the chat box if you want. Any volunteers? Okay, so I'm going to move on, but please keep in mind this is not the best. Okay, and just like I'm trying to encourage you, just please speak up. Yeah, you shouldn't feel like shy or like you have to participate. You have to speak up. You have to if you're having like if you don't understand anything or like you're not following or anything, you have to to say so. So like you can basically benefit from this as the most yeah, because just me saying stuff is not it's just like it's not going to be very useful if you are not like discussing basically. But okay, let's move on. So basically just if you understand what is the difference between this is basic in statistics. So what's the difference between a sample and the population? So the population is the whole thing you want to describe, but a sample is the data you have access to. So basically, a descriptive statistics is like focus on describing a sample, while inferential statistics is like basically trying to make these predictions about the whole population. So, for example, if you want to collect data, so sorry, if you want to measure something like nationwide, let's say income, for example, you want to measure like you want to like make prediction about the income of people nationwide. You might collect data. You make a use a survey to collect data from a sample of the population. So you're not going to like if you like the country has like I don't know how many people are in Ethiopia, but like let's say 40 million people. You are not going to collect data for 40 million people. You're just going to collect a sample, have to be a representative sample of let's say 1,000 people, and then this describing computing statistic for this sample of 1,000 people is descriptive statistics, while from this data after you make these computations you can infer information about the whole population of the 40 million people. So this is different between a sample and a population, and basically the difference between the descriptive statistics and inferential statistics. Okay, so in short, like again, so again, this is the same definition I just said. Descriptive statistics helps to describe the data set you have at hand. And the common thing they can compute is something like the mean, the median, the mode, the standard deviation, the skewness, so the distribution of the data, and how can you describe this distribution in different like statistics, different measures, different values they can compute. I would ask you to define what are these. I intended to do that, so I'm not writing any definitions. But like I have a feeling that you're not going to to participate. Okay. So like can let me just ask, like, can you clarify what is the difference between the mean and the median, for example? This should be like I'll give you a minute. So what is the difference between the mean and the median, for example? I expect that like in task one, is it task two actually? I think. We check. Yeah. So in task two, rather it is in task one actually. So on the task two, yeah, that you have to compute different descriptive statistics. So like you're computing averages and yes, someone. Okay. Yes, exactly. Correct. Yeah. So vibrato, I hope that I'm saying your name correctly. So the mean, yes, is the average, while the median is the midpoint. And yes, so basically for some distributions, you will have the median and the mean are the same. If you have a bell curve, for example, but if your data is skewed, for example, skewed meaning that like it basically just like is basically skewed to one side, like it's more to the right or more to the left from the median, then will have difference between the mean and on the median. So these values basically tells you some like each one of them tells you something about the data you have at hand. So the deviation is like how much it is scattered, your data, and so on. So okay, so this is descriptive statistics. Thank you for answering. Or okay, inferential statistics, on the other hand, is about making prediction about the full population, as I said before. And here, like there are different types of analysis here. You have hypothesis testing and construction of confidence interval. And okay, so these are like statistics or simple. These are like more complicated stuff. So you have, so I'm not going to go into what is hypothesis testing is, but I'm assuming you have some idea about this, but okay. You have also correlation analysis, which is when you assess the relationship between two variables, whether they increase together, decrease together, or like, are they like unrelated at all. And like one measure of correlation is the Pearson correlation coefficient, which is like also like you have to compute at some point during in this challenge for your data. So and the third thing is the regression analysis. This is where also you're finding relationship between variables, but here you are finding the actual mathematical relationship between them, right? So like basically finding maybe that like the parameters of the line or the parameters of the relationship between the two variables, or more than two variables as well. Okay, so this in short. Any questions so far? I'm going to go a little bit about quantitative analysis in finance, but this is just like an example. Any questions so far? Okay. All right. So I will assume that everything is clear. If there are no questions, but you can ask at any point. All right. So is there one particular like field in finance, and because you're dealing with financial data for this challenge, the quantitative analysis is like one part. It's an approach for determining the value of a financial asset, or like for developing trade strategies in finance, basically. So it's basically, yes, so it's when you depend on mathematical and statistical analysis. So it's just like one application of quantitative analysis. So here, what is used is data from the stock market, for example, like historical market data, to develop trading algorithm and computer models, basically to analyze investor opportunities and risk and computer risk. So yeah, so the goal, of course, is to assist in making the most profit or reduce risk in trades. Okay, so the difference here, like again, between quantitative and qualitative, is that like quantitative analysis in finance is when you are depending completely on numerical data. So like when making trade strategies or trade decisions, you just only depend on numbers and you're not collecting any other kind of data. In quantitative analysis, this will be like when the analyst will be collecting data or making research about like the companies, like when like deciding how to trade with a particular stock, then researching the actual companies, the products they produce, and like the management team or whatever, and then basing their decision on their opinion or subjective um, opinion of how this company is going to fare well or not. And both are important, of course, but and they have their uses. But this is like basically the main difference between the two things. I'm including this just to like because it's a clearer example of or clearer explanation of like what is the difference between qualitative and quantitative. So yeah, so this is just like blah 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 about this. So it's quantitative is has a good like advantages of being consistent. Like it can be applied consistently, and it's basically because it depends on numbers and patterns and like an emotional. You can just make it basically can create completely automated trading strategies in the high frequency trading. This is like when trading decisions are taken very quickly. So this is just completely automated depending on a computer. So you can have triggers for trading that are like just based on numbers. They are not emotional. They are not subjective. They are applied consistently. They are cost effective, of course, because they are depending on computers, not on actual people. So it's less, it costs less. The disadvantages, of course, also of course, but like the disadvantages of this is that there are things that are not basically the data. The numerical data is not everything in finance. There are other things that are important, and this matters especially for like big inflection points. Like these are things that are maybe not very predictable by the numbers. Like big financial events, like great recessions and stuff. Things can like experts can maybe see the signs for it, like in qualitative data, but not in the stock market data and stuff like that. So yeah, both have like their uses and advantages. Okay. Okay, so this basically conclude our like introduction to quantitative analysis. So any questions before we move on to the time series analysis? Anything? Like I know this is just brushing over like the basics, really not explaining a lot of the things that are involved. Like we're not getting into the math actually. So okay, also we can let me know how you feel. Like is this okay? This is a question. Almas?
Yeah, can you explain to us when to use the quantitative and when to the qualitative analysis?
Okay,
What figure for that? Yeah.
so okay, so basically it depends on the kind of data you have, first of all, and the goal you want to reach. So if you have numerical data, that's when you can use quantitative analysis. Qualitative analysis is used when you don't have numerical data. So this is basically based on the data type, also based on your goal. If you want to have something that is rigorous and consistent, you are more like so this is generic. So you are more like for you should be like using quantitative analysis. I'm going to say just in your case, here we're talking about qualitative analysis just as a contrast. What you're going to be doing is just quantitative analysis. Qualitative analysis, like this, depends on having like knowledge in a particular expert knowledge in a particular field, and then it has its own um, like like rules and measures and stuff you can use. In your case, what you're going to be doing basically when you're using data engineering or machine learning, and is all quantitative analysis. Yeah. So, does this answer the question? Is this clarifies it? Okay. Yeah. So it's just like included for a contrast. Okay. So, any other questions? So moving on to time series analysis. So time series analysis is the analysis of data points collected over period of time. Okay. So this is like what it makes it. It's a particular kind of quantitative analysis, but here we are dealing with data points collected over a period of time. So this is what is a time series. A time series is data points collected over periods of time. So they are collected usually on um, equal intervals. So just an example, it can be okay. The obvious example is stock market data, like the ones you have. In the data you have is all you can describe it as time series because you have um, like data collected over time. So the stock market data is collected every day, for example. Like every day you have one point of data. Like say you are looking at the, let me actually share, just look at some data here. I can't, so I need to reshare my screen. I'm just going to be just okay. So this is one of the CSV files you have, AAPL historical data, the CSV file, and you can see like you have these columns. So I'm looking at the CSV file itself, and so you have the date column, the open, high, low, close. So this is the price of the stock at open, the highest point, the lowest point, and the close. And so each row of this is so this is a data point in this particular date. This is a data point the day after, and so on. So this is each data point from the next is one day, or the same like period of time, basically. So this is how like this column is a time series, and the whole data is time series because it's all collected over equal intervals of time. The other data set you have, I cannot actually open this because it's too big, but okay. Like you can look at it here. So you have headlines, and they are also collected over, like you have the date. But here, like maybe it's not, so just, I'm just going to point. Okay. Yeah, so basically, when the data, you have data points collected over equal intervals of time, this is a time series. If the data you have, it can be collected over not equal intervals in time, and basically you can convert this, if you don't have equal intervals in time, you can aggregate if you have multiple values for the same period or the same point. And
Sorry, are you sharing the screen?
no, I'm not sharing a screen. I
Not
stopped
sharing, just
sharing.
give.
Yeah.
Okay.
Yeah, let me share. Sorry. Yeah. I stopped sharing because okay. Now you should be seeing my okay. So here, like there are examples of time series data. So it can be like rainfall measurement collected like maybe every day. Stock market data. This is also collected every day. Temperature reading can be also collected every few hours, like or something like that, and so on. These are all time series data, and time series analysis can be used with any kind of this data, with any of this kind of data. Okay, so so there are like when dealing with time series, we can think of like the patterns that can happen in the data. So one pattern, like there are like different types of patterns that can appear. Um, so like let's take this example. It's a railway passenger data. So this is a count of passengers at different times during the day. Okay. Okay, so this is like the different times of during the day, different hours, and this is the number of passengers. And you can see here like that starting from early morning, the number of passengers increases till the mid of the day. But also there is fluctuations, right? Here, like maybe every hour or so. You can see the number increases and like decreases here. So these are two types of pattern, basically. The trend is over time. Like when you look at this data is increasing over time. This value is increasing over time. This is a trend. Okay. So this is over whole time. Seasonality is a cyclical pattern, something that is repeats over like a certain an interval of time. Like here we like maybe we notice that every hour there is like some kind of pattern that repeats. So you can, when you are looking at the data series time series data, you can basically isolate these trends, this pattern, sorry. So with a different between a trend and a seasonality in your data that you can see. Of course, like the easiest way to see this is to plot it like this, like a line plot like this one can make it can make it easier for you to observe. Of course, there are things that you can compute also to measure this. So the kind of time series analysis. So what you can do with the time series data. So there is like classification. So basically identifying and categorizing the data you have. You can have curve fitting, which is basically plot different data and investigate the relationship between the variables in the data. Again, you have descriptive analysis. Remember the descriptive analysis that we talked about before. So identifying the patterns in the time series, the trends, the cycles, and the seasonal variation. The explanative analysis. So here is like when you are looking for cause and effect. So this is like looking for causation not just the relationship, just as the actual causation between data. This is, of course, is you know, was important thing about the difference between correlation and causation. I hope you know this. So in causation, so like one important thing in to know that one variable caused the other or affected it is that it can happen before. And in time series, you have this measure of time basically. So you have that to consider. Um, and so these are different types of time series analysis. So like you might not need to do all of this in this challenge, but like yeah, I'm just like listing them. It's not even comprehensive. Okay. Okay. So in one important thing that you can do with time series data is or one important use is forecasting. So remember the example we talked about, it's weather, the temperature, or any kind of other weather um, measurement like temperature, humidity, like wind, whatever, all other variables you can have can be used to forecast the weather in the future. So in time series data, you have historical data, and you can use it to predict what will be the value in the future. So another example is a stock market. So stock market is you can when you have historical stock market data. So like the one you're looking at. Open it again. So like it can be very useful for you when you are devising trading strategies. So knowing, let's say, so the data here we have is actually from the 1980s. So forget about that. Consider it is actual. I I guess at that time none of you were born, but okay. So consider this it was like current data. Say it was like about 2023, and you have this data and it stops at some point of the current date. Um, and then you want to, if you can predict the values for the future days, you can basically uh, devise a profitable trading strategy um, uh, on that. And you can basically, whatever like forecasting method you use, you can like test it on historical data and then apply to the future for your use there. So just generic thing about this, there are different uh, methods for forecasting. There is the classical statistical models. For example, there is a moving average, exponential smoothing. So moving average is the simplest thing you can think about. Is just like yeah, so moving average is like you take an interval and you calculate the average for this. So like if you have stock market data for every, so this is like say every daily data, and basically you can take like 5 days and take the average for them and see like how the trend like how the trend goes compared to the moving average. And okay, so these are just like I'm not going to explain everything here, just like names, can look at them, can look them up, or maybe you already know about some of about this. So like this is statistical models. There's also the use of machine learning. So this is machine learning algorithms can be used for forecasting, have linear regression, and like a random forest, machine learning models with reduction methods. This like can be applied here for time series forecasting. There's also deep learning, the use of a recurrent neural network or long short-term memory networks. These are like particularly devised to work with time series data. I hope you already know at least basically what is how neural network work and what is an maybe generally what is an RNN or LSTM a network is. Sorry. So there is another like maybe emergent way to forecast. I didn't write it here, but also the use of large language models for forecasting, or rather more accurately transformers, like the models that behind like ChatGPT. These are very large models. They are neural networks. They are based off neural network, but they are like a particular structure called transformer. And there are models. These models can also be used for forecasting. The same way they deal with language. So the same way they deal with yeah. So when they predict the next word, they can also be used for forecasting um, the next values in a time series. Anyway, so this is just an overview. Um, I don't know if I hope it was kind of illuminating or like structuring how this like two major analysis fields in general. So, do you have any questions? Let's stop here. Any question, anything you want to like maybe dive into more? So there is a question here, maybe I didn't see it before. Sravel is asking why it is important to calculate all measures, mean, median, mode, variance for a data set. Well, you don't necessarily need to calculate all measures. It depends on what you are depend on what you want to get from your data set. If you're trying to understand your data, you can do like many things in the ADA, is the explorative data analysis. And this includes calculating these different measures, because each one of them tells you something about the data. The mean tells you something, the mode tells you something, the comparing the two tells you something about it. The standard deviation or the variance tells you like how much your data is scattered. And other things you can do is not actually calculating, but just plotting or trying to see these different things. So in the ADA, we're going to be plotting your data and seeing how the distribution looks. This is important to understand the data and to try to see if there are any patterns. If you are trying, so your goal is to predict something, you maybe want to see if there are patterns or relationship in your data. So you have multiple variables in your data, then you can plot them in a scatter plot, for example. It's one thing you can do, and see if there is an obvious relationship between them. If your data, how do you know your data is two variables are related? The scatter plot. Let's say if I can find a good example, a good plot here. This yeah, so like this one, nice plot here. I'm not going to be able to see it. Oh, it's too small. Anyway, let's see if there's another one. Okay. I want to have a good one that is kind of linear, but they are not really. Okay. In this data, you have I don't know, it doesn't matter what it is exactly, but there are two variables here plotted in this scatter plot. And if you look at the values it's themselves, you're not going to understand necessarily. Maybe your data is too big cannot really understand just looking at the data. But when you plot it, you can see clearly that as this variable increases, the other one decreases. So there is some a linear and negative relationship between the two. So the correlation between them uh, is negative, and but there is a real relationship between the two things, the two variables. Other plot like this one, I'd say, so you can see this one here. Let me remove this one. Sorry, can see it here. So well, the person plotted a line, but really the data is very scattered. There is no, you cannot really predict that there is a linear relationship or in any regression. You can measure the square root error so to see how bad is this or how far your data is from this predicted relationship. Anyway, I'm just saying you calculate these measures and you do other stuff to understand the data and see the patterns in it and try to it will help you if you are looking to build a predictive model. It will help you just understand and decide what kind of model you can use basically for that. Mose? Okay. Okay. So how common is the use of time series forecasting in the real world, especially in the financial domain? How common? It is very, very common. So hopefully I think in the next challenges you're going to see this even more. Um uh so yeah, try to understand this, the basics of this to see it, because like yeah, the data you have, again, I mentioned multiple examples in here in time series data. So I mentioned like weather, I mentioned trades or financial data. These are all time series data. They change, like these are data collected over time. You can arrange it in a time series and you use historical data to predict the future. So these are all domains where time series forecasting is very common. So it's very common in real life. Okay, so basically in a financial in particular, because this is very competitive, it's a lot of money there, and coming up with like the right strategies for based on forecasting is like have like can give you a profit or lose or avoid losing money basically. So yeah, it's very common. Any other questions? I hope like I answered your Mosero. I have answered your question. Okay, any other questions? I think were there like people who had their hands up? No. Okay, Almas.
Maybe if you can tell us if there is a special tools other than what we know to work on the quantitative analysis and time series analysis, and if you have
Sorry.
if you have any demo, we'll appreciate also
Uh,
showing us the tools we have to use for this kind of statistical analysis.
okay, so for your purposes for this challenge, you are like basically when using if you are using Python, using pandas, the pandas library is very good for like doing a lot of this statistical analysis, and also all this ADA, so the plotting and everything else. So like the tools they are like described for you in the challenge document basically are sufficient, and I think they're good. So I don't have, I'm sorry, I don't have a demo at the moment. Maybe can rectify this later, or like maybe can prepare something for a later date. But yeah, I don't have extra suggestion beside what you have in the challenge document at the moment. But basically, if you look up, depending on what you want to do, there will be different. So like we talked about a lot of stuff. I'm just focusing what you have on the in the challenge, what you are like required. Sorry, what I said in, we covered a lot of stuff on in the presentation. So these are like wide stuff about like just overall. But what is required for the challenge is like something like you don't have really forecasting in the challenge for this week. And so maybe you don't have to worry about that. But like, of course, if you want to consider tools for doing everything in what was talked about in the presentation, there will be like many tools for anything there. And yeah, so I'm sorry if my answer was very satisfactory, but yes, I don't have a demo, but I would say like stick to like the suggestions in the challenge document for now. In the future, you will be seeing more stuff from this, and more tools and more methods and so on. Okay. Any other? Okay. If there are no other questions, you can stop here. If you have further questions about anything, you can like ask on Slack. Yes, you can like mention me. My name is Imtinan, and or any other of the other tutors, and like just write your question as you already like doing, I think. So